Okay, this video shows how to use Mathematica to solve problem 1648. And as usual, I do a quit here at the top, just to, in case I've been using Mathematica before. I just want to make sure that it forgets everything otherwise that I was using before, otherwise you could get confused. Okay, so here are the standard IJK. Should be second nature now. All I'm doing here is defining cosines and sines, so it makes the typing easier. And getting a little bit ahead. Okay, get caught up now. The next thing, like I said before, once you do the problem on paper, you know what points you're going to use, you know what your radial vectors and your R vectors and all that stuff is, and so I like to define it up at the top. O has got zero velocity, which I'm doing here. Then VA has got to be vertical. The acceleration of O is zero. The acceleration of A is vertical. What you've seen in the past is I do the velocity and then the acceleration. Now I'm just putting them all together. This is that equation for the L. L is equal to V over the cosine. This is a direction that points out the slot, and so that helps me to write the REL equations. Here is the R vector. It's simply L times, or in the direction of the O to A. Here's your omega and your alpha terms, okay? And so now all I'm going to do is I'm going to write the velocity equation. So V equation is, and this is one equal sign right here. Okay, so I'm naming this equation the V equation, and it's velocity of A. There's two equal signs here, so this is an equation. Velocity of A equals velocity of O, omega cross R, plus the V rel, which I don't know that number. It's just a number, but it's in this direction here. It points out, so I'm assuming that there is a speed going out that link. My acceleration equation mimics the velocity equation, so your AA equals AO plus alpha cross R instead of omega, and then it's omega cross R, so that's the non-simplified version, but Mathematica do two cross products real quick. And then because there's rel terms, there's two cross, omega cross V rel. Notice that the V rel is a speed, which I don't know yet, but I'm going to solve for it out the link, and then there's an A rel, which goes out the link. And so then we'll execute this one. So I'm not sure I executed this one. Let me do that. Okay. And now execute here. So you define your equations. And you just do a sanity check. Because everything is two dimensions, your K directions should all be zero. Not sure if I don't know what I did wrong here. Let me just re-execute this. I don't know what that find instance is. Okay. So notice that this term here is zero. The K term is zero. Here's the I. Here's the J, and the K is zero. So I'm just doing a sanity check. Over here is the I component, comma, J component, comma, 0 for the K. So it looks right to me. I don't know what that find instance is. I'm just going to delete it. Okay, so then all I do is I solve the velocity equation, and there's two unknowns in there. There is the V, because VA was equal to, notice VA was equal to speed vertical. So I'm going to calculate the speed, right? I'm solving for the speed, and I'm solving for the magnitude of the V rel term, right? So that's the solve. The simplified just says, do some algebra simplification to make it look pretty. So I'm going to execute that, and you get these values right here. Much easier to do than doing it by hand. Now here I was just checking the work that I did by hand to make sure that I had the correct values when I was doing it by hand. So I copied the this guy. So I just copy and paste. So I went like this, and I pasted it in, copied, and I pasted it in right here. So that's what Mathematica is saying. And then if you look at what this is, between these parentheses, this piece right here was what I got by when I did it by hand. And I'm just trying to confirm that those guys are equal. So I just take what Mathematica gave minus what I had, and I just simply said simplify that. Well, I get 0, which tells me that what Mathematica is saying is correct, is exactly what I had by hand. So anyway, that's how I knew that I had done it right by hand. Okay, so then you need the VREL term in the acceleration. So all I did was I just copied and pasted. So here's the VREL. So I selected that, copied it, and then just did a paste and pasted it in down here. And then I executed that so that it knows what VREL is now. And also I just made sure that when I solved it by hand, I actually got 0, which I did. So that just confirmed that when I solved it by hand, I got the correct value. Okay, so now I'm going to solve the acceleration equation, and I'm going to solve for the magnitude of acceleration and the AREL term. Not that you really need the AREL, but I went ahead and did it anyway. And then I just simplify it so that it looks nice and pretty. I'm going to call it acceleration answer. So execute that. It comes up and says, okay, the magnitude of the acceleration is this piece right here, and the AREL term is this piece right here. Okay. Now, what I wanted to do was to make sure that the A term that I got by hand was equal to the A term. Actually, I'm doing the AREL. Okay, so I copied this guy, pasted him in down here. So that's the Mathematica calculation for AREL. And then this term right here is what I had for AREL by hand. And I just wanted to confirm that those were also equal. In other words, I'd done it by hand correctly. So if you execute that, you get 0 as well. And so I knew that the hand calculations were right. Okay, so the solution that they're looking for is the acceleration, and it's that term right there, which is exactly the same as what I got by hand. Okay, so that's it.